Oh man, you guys missed it. My dogs were just in the middle of a massive battle. For my honor, I think. Speaking of honor, I think I promised my honors class that we were going to have a little review before the test, which for period 4 is tomorrow, and for period 3 is the day after that. Let's see, tomorrow's a C day, so period 3 is Jeopardy tomorrow. I'm pretty sure. I don't think we did Jeopardy for period 3 yet, which means that Friday would be the test for period 3. Yeah. So anyway, here's some vocab. Bam. I went over pretty much this whole entire thing with period 4 earlier today, and I will be going over pretty much the whole entire thing tomorrow with period 3. So I'll go through a small amount of this today on my own, if no one shows up. If people show up, then you could hear my dog. He's still recovering. It was it was an epic confrontation, the likes of which I don't think I've ever seen before. Something truly special. I mean, it was like Tyson Holyfield. It was like Ali versus Frazier, part 8. All right. Oh, what did I just do? I shrunk something. No, I didn't. All right. So yeah, nobody's here yet. Let's move this over to the side. Careful now. Careful. Careful. Okay. Whew. Could have gone really, really horribly wrong. Not really. But it added drama, didn't it? Alrighty. Number 1. How do the terms DNA, gene, allele, phenotype, trait, and variation relate? Oh my god, that's a lot of traits. Also, did you notice that fitness is crooked? I'm not sure why, to be honest. But it's crooked. Or at least it looks crooked. I guess it's not crooked. It just looked crooked because of the way I was sitting, I guess. I'm kind of far away from the screen right now. Either that or I'm having some massive vision problems. I don't know. So essentially, your genes are your DNA, just sections of DNA that code for traits, right? Now, the specific gene you get is called an allele, and you could have a gene for hair color, for example. Now, your hair color allele is specific to you. For example, you might have blonde hair, or brown hair, or black hair. So obviously, you would have the alleles for that hair color. So the variations of the traits that you get are given to you by the alleles, which are types of genes or sections of DNA. And phenotype is just a vocab word that means trait as well. So threw that in there. For types of evidence, with a lot of evidence for evolution, what you're trying to do is you're trying to show that two different organisms have a similarity or a similar template that was built off of and changed over time, because evolution is change over time. So in order to show that something has changed over time, you would need to show that A, they started the same, and B, that differences have accumulated. So whether you're looking at fossils and you're comparing maybe an older fossil to a newer fossil, 150 million year old fossil to a 50 million year old fossil, or whether you're comparing a fossil to a modern day organism, that would be essentially the goal, is you want to show, hey, similarities, started out the same, and B, there's been change over time. You could take that further and look at something like biochemistry. We did the amino acid lab, so you were able to see, again, similarities in those amino acid sequences, which are due to similarities in DNA, but you also saw differences. The less related you are to an animal, the more differences you had in that sequence, showing that the more time separates you from an organism in terms of having a common ancestor, the more differences we're able to accumulate. It shows that change over time occurs. Okay, so for example, humans and chimps, we had a more recent common ancestor than fruit flies. So we would see a lot more similarities in the amino acid sequences of us and chimpanzees than we would in us and fruit flies. Harvey Weinberg we could skip. We'll probably go over that after the test, but we just didn't go over it before the test. I don't really care about putting it on the test specifically. We'll probably, after the test, we'll have a little thing where we go over Harvey Weinberg. And if you're going to AP Bio, then you'll learn even more about Harvey Weinberg. So we'll touch on it, but just not for the test. You don't have to worry about it for the test. 7. Bell curves are evidence of? Well, when we're looking at bell curves, we're usually looking at what trait appears more frequently in a population. So bell curves are evidence of natural selection usually. It's evidence of, hey, a certain variation shows up more because it was better for survival. It got selected. 8, that you can look in your notes, and we could go over it tomorrow if you need to. Except period 4, we already went over it today. Same thing with, number 9, I used the picture of a puzzle. All the pieces were put together, except for one. And everybody was able to tell me that, hey, look, that's a heart. So the question was, how do you know that it's a heart? Doing number 9, of course. I can't highlight. There we go. My mouse is just not good. So how do you know that it's a heart if you don't have all the pieces? Because you have enough pieces put together in a way that makes sense, that you can clearly see what the full picture is pretty much supposed to be. And that's what a scientific theory is. You have all the pieces, all the evidence, you've tested, you have lots of facts and data to show, like, hey, this is not just a guess. It's not just an idea. This is something that many facets of it are proven. All the ways organism can develop a new trait or variation of a trait via a genetic change. Basically mutation and reproduction. You can end up with a trait that's different from both your parents through reproduction. And then obviously mutation, everybody knows, gene change. Number 11, that's a good question. And we'll go over it tomorrow. Same for number 12, 14, and 15. We did not go over the term coevolution, but it's not exactly rocket science, especially because this right here is me telling you what it means. So I want you to read what that says and try to answer this question on your own. Do a little bit of thinking. Same thing with adaptive radiation. We did not go over that term, but it's not a difficult concept. So for coevolution, I clicked, I dragged, it highlighted. For adaptive radiation, I click, I drag, it doesn't highlight. I don't know what the problem is. My mouse stinks. I mean, I know what the problem is. My mouse stinks. So I guess I don't know why I said I don't know what the problem is. 15 is another adaptive radiation question that builds off of this one. And again, period 3, we will go over 14 and 15 tomorrow. Period 4, we already kind of went over it. My other classes, you don't have to know that at all. How do terms like mutation, variation, and allele lead to natural selection, or relate to natural selection? Well, the variations that we have, like being taller versus being shorter, they get selected by the environment. Alleles, of course, give us our variations because the alleles are your specific genes. And if you get a mutation, then that would lead to you getting a new variation, potentially, that could help you survive even better. So mutations can give you the specific genes, the specific alleles, that give you your specific variation that determines whether or not you're best suited for survival in the environment. This is another question 19 where, again, we didn't go over the term, but I spell it out right here. Basically, it's when animals develop analogous structures, structures that appear similar but are randomly developed on completely different evolutionary pathways. For example, fly wings versus bird wings. They both have wings, but they did not get wings. They did not get that analogous structure from a common ancestor. So that's not even a question. I just told you what convergent evolution was. I don't know why I did that. I should have left it open, but I didn't. And last one is this. We already learned the terms geographic isolation, behavioral, and temporal isolation. Geographic is when there's a physical block that you can't physically get to one another, so you're isolated. Behavioral, there's a choice involved. Maybe it's a choice based on coloration, on mating dance, on mating call, whatever. And so groups become separated. They stop reproducing together because of that. And then there's temporal, which is time. Maybe one reproduces during the day, one group reproduces during the night, so they never reproduce with one another. Maybe it's a seasonal difference, a monthly difference. And so you just have to look up these and figure out which isolations go with which of these terms. Okay. Genetic drift. Make sure you get that. That's we pretty much every class. I think we just did that lab this week, where you had to grab pink or white flowers. Pink or white did not give any sort of advantage. It didn't matter whether it was pink. It didn't matter whether it was white. You grabbed it because of luck. And once more of a certain flower existed in your pile, what likely happened is that you ended up grabbing even more of that color next time, or maybe 2 rounds later, and then eventually you just either wiped out one color completely, which if you went like 10 or 20 rounds, you probably would all have done, or at least you just end up with a lot less of one color than the other. These are all vocab terms that should be right in your notes. We talked about the types of isolation. So that's it. Quick little 12-minute stream. Nobody on. Nobody with any questions. So I'll try to keep an eye out for any comments. So if someone has a question, they show up later, you can leave a comment, or send an email, and then leave a comment anyway. That way I know that it just gives another way to alert me. So more ways to alert me that you left a comment, the better. All right. Good luck on your tests. And I am out of here.